activity on my favorite program, Geometer Sketchpad. Before we get into that, though, a little bit of vocabulary. So far this chapter, we have been talking about finding segment lengths in triangles. Remember, we started with tangents, lots of Pythagorean theorem. And Monday, we talked about arcs and chords. Still a lot of Pythagorean theorem. We're switching gears now and dealing with finding the measures of angles. Before you can find the measure of an angle, you need to be looking at what arc it's intercepting. If you look at that description of learning at the top of your notes, the first thing that you must know in order to accomplish anything in this lesson is be able to look at the angle and identify the arc that it's intercepting. So I think I have it in your notes earlier than it is on my screen. But one of the things that you'll probably hear me say whenever someone doesn't see the arc that the angle is intercepting is I'll ask you, what's Pac-Man eating? See Pac-Man? See Pac-Man? I'm old, aren't I? You all don't know who Pac-Man is, do you?
Yes, we do.
Yeah, you do? Okay. I was about to get dizzy. All right, so central angles we've talked about before. For example, angle 1 is a central angle. Its vertex is on the center of the circle. We've talked before about how the measure of that central angle is the same as the measure of its intercepted arc. What I want to talk about today is the measure of an inscribed angle, which would be like angle 2 in this diagram. Notice where its vertex is. Its vertex is on the circle, right? So, thinking, yes. Where did my stuff go? Okay, so I've built these circles so that you can go up and click and drag a point and notice the relationship between the angles and the arcs. You all love coming up and playing with my technology. Please play with my technology. Someone? No? Not today? Alyssa, I can always count on you to play with my technology. No? Click and drag a point. Click and drag. Oh, click and drag. Woo, it's a numbers dance. Can I do this one? Sure. Okay, so what I'm wanting you to notice as she's clicking and dragging the angles is, or clicking and dragging the points, is the relationship between the angles. So notice that she clicked and dragged point C, and those angles dance. And first of all, property that a lot of you want to kind of spit out very frequently is they're congruent. But, oh, Brianna's shaking her head. No, they are not congruent. Helena? Which angles are you saying will be? Go ahead. Thank you. Opposite angles of a quadrilateral inscribed in a circle, absolutely, will be supplementary. So you see that somewhere in your notes that no matter how we click and drag these angles, notice that those opposite angles of the quadrilateral are supplementary. You see that somewhere in your notes where you can fill in the blank for that property. There's two other things that I'm wanting you to notice up here. Anyone else feeling like clicking and dragging? No? Oh, there you go. Oh, Helena, hit it. Okay, so we already have a property for the one on the right. We haven't talked anything about what's... Okay, C is fixed. Try clicking and dragging the point A or B. All right, well, that didn't change the angle. How about if I click and drag point A? Okay, and that angle is not budging. Why? Why is it a right angle? Okay, so what do you notice? Thank you, Helena. What do you notice that was always the same in this diagram? All right, but what else? Segment AC, for example. What do you notice about segment AC? It's always the diameter of the circle, which means that arc AC is always the same arc. It's always a semicircle. All right, someone else? The last one? No? This is Clouse, you can do that. Alyssa. Have at it. Okay, so the central angle, remember we talked about this before, the central angle and the intercepted arc are the same. What's new to us today is these inscribed angles. Any thoughts on how we're going to find inscribed angles from here on out? What do you notice, perhaps, about the inscribed angle, Grace? It's half the intercepted arc, absolutely. So hopefully you've kind of followed along with your notes and seen that the measure of an inscribed angle, as Grace just told us, is half the intercepted arc. And that an angle inscribed in a semicircle is 90 degrees, or a right angle. And then opposite angles of a quadrilateral are, what did we notice? We noticed that they were supplementary. Oh, that was funky. So in problem 1, we're asked for the values of A and B. Please notice the difference. A, ladies, A is the measure of an arc, whereas B is the measure of an inscribed angle. So, arc A. Any thoughts? Where did you get the 108? You would not add those two things together. Be careful. Think about what we realized earlier, that the measure of an inscribed angle is half the measure of its intercepted arc. Okay, so let's talk about all this stuff that we have in here. The A is an arc, the 56 is an arc, the B is an inscribed angle, and the 52 is also an inscribed angle. Okay, so 52 is an inscribed angle. That means it's half of its intercepted arc. What arc is the 52 intercepting? Not just A, be careful. If it helps, once again, tracing, say that again, Alyssa. The A and the 56 put together, absolutely. So, how are we going to use that to find the arc A? Grace, was that your hand? Absolutely, yes. Double the 52. And then do what with it, Grace? Okay, she started us off. Someone want to finish that? Subtract the what? Not from 180. 180 involves a semicircle. I have no guarantees that anything up here is a semicircle. Grace, now you see it. Subtract the 56 from it, yes. A will equal 104 minus 56, giving me 48, thank you. Okay, so realize you're going to be working backwards sometimes. For angle B, we already talked about how angle B is an inscribed angle. So I know it's going to be half of its intercepted arc. What is the intercepted arc for angle B? Say it again, please, Helena. Right. So angle B is half of 56, giving us 28 degrees. If you haven't already logged on with your CENTIOs, please do so, as the your turn on the next screen is a CENTIO question. We have from this screen what we need. In order for me to have a semicircle, I have to know that something is the diameter. At no point did they identify where the center of the circle is in this diagram, so that I can't assume that I have a diameter anywhere.
Are they all going to be
Yes. Yes. Okay, so in your centile, all you're logging in is the measure of angle A for part B. Oh, no. It hates me again. All right, well, you have your turn to be working on while I'm trying to figure out why my technology doesn't like me. Give me 1 second, Austin. Let me just restart this program. Yes, sir. Okay, so angle A. There's only two kinds of angles that we can talk about in circles: central angles and inscribed angles. Is it one of those? It's an inscribed angle. Do I know about the measurement of inscribed angles? Like half of it. All right. Also, notice this time, unlike in this problem, we are identifying where the center of the circle is. This is the diameter. Why? An angle inscribed in the center of the circle. Oh, yes. Here it is. Angle A. That is the original flag. Angle A is an inscribed angle. After the intersective arc. Okay, so why not on this? So here is A. Exactly. Oh my goodness. Yeah, the Centillos are not cooperating, so just don't even worry about that. I'm on my way to it. Okay, so angle A, attacking an evening. 190, right? So, inscribed angle is half of the intersected arc. There it is. There it is. Yes. What is attacking an evening? Angle A. Okay, trace angle A. Okay, the angle is attacking a big mountain. That's attacking an evening. It's always apart. Here's angle A. Yeah. Reading apart. Always reading apart. Yes. Oh, so you should be opposite. So you're not doing okay, so one of the things that might be helpful is the angle that I did here. And the repeating is the x mean side of the angle. Just like in this one. Feel better? Well, inscribed angle, no. They have to, yes. Like this. It's what means side. That angle. Always apart. Give me 1 second. Get rid of this thing. Okay, from what I'm seeing and hearing, we either got this or we're kind of stuck-ish and I need to unstick you. So let's talk. In number 1, part A, most of you had no difficulty realizing that angle A, because it's an angle inscribed in the semicircle or it's intercepting the semicircle, however you see it, angle A is 90 degrees. In part B, you're finding 4 different angles of this quadrilateral. And once I kind of reminded you about look for what Pac-Man is eating, a lot of you saw it pretty easily. So starting with angle A, here is angle A. If you're having trouble seeing Pac-Man's big mouth, then extend the sides of the angle, as I've done here. The arc that it's intercepting is what's between the sides of the angle. Gentlemen and ladies, I'm seeing the phones out. Don't complain about how confused you are if you're sitting there. Okay. So angle A is intercepting this 190 degrees. So the measure of angle A is half of that 190, giving me 95. And then you're going through that same process for angles B, C, and D. Angle B, what arcs is angle B intercepting? The 64 plus 90, so that's 154 that I'm taking half of. Measure of angle C is half of the arcs it's intercepting, the 106 and the 64. So that's 170, giving me 85. And measure of angle D, here's angle D, here's Pac-Man's big mouth. It's opening and eating this 106 and 100. So 206 is that sum. Take half of that, and that's 103. And again, yes ma'am. She's on fire, yes. What I was about to point out was that first observation that we made this morning when we were clicking and dragging. Remember, opposite angles of this quadrilateral will be supplementary. So once you find angles A and B by taking half of their intercepted arc, remember angle A will be supplementary to angle C, and angle B will be supplementary to angle D. Trent, you all right back there? All right. We have from this screen what we need. So how about if 2 inscribed angles are intercepting the same arc? What do you think will be true about those angles? They'll be congruent because they're cutting off the same arc. They're half of the same arc. So angles inscribed angles intercepting the same arc are congruent. Problem 2 is talking a little bit more about stuff that we were dealing with before. Half of an inscribed angle. Angle 1 in part A here, that's 90. Angle 2, notice, is intercepting the same arc as the 43. So then angle 2 is 43. Again, the Centillos aren't cooperating with me. If you haven't already, just turn them off. We'll put them back in the case at the end of the class. Okay, you should be working through this your turn 2 within your group. Fantastic. Good. Okay, so let's find angle 4. Okay, let's see what the right angle is. But it does. Fantastic. And then we do have to be opposite angle of quadrilateral. So 4. All right. Angles 1 and 3 should have come easily to you. They are both 90. Gentlemen and ladies, let's refocus, please. Angles 1 and 3 are both angles inscribed in a semicircle. We know that they will be 90 degrees. Angle 4 would probably be the next easiest angle for you to find, because notice it is an inscribed angle, and we know the measures of the arcs that it's inscribing. It's intercepting, rather, that arc measuring 140 degrees. So since it's an inscribed angle and it's intercepting a 140 degree arc, I take half of that. And I get that it's 70. And then if you remember that opposite angles of a quadrilateral inscribed in a circle are supplementary, angle 2 just kind of falls out of your mouth after that. It's 110. We talked earlier in this chapter about how when a line intersects a circle at exactly one point, we call that line a tangent line. What we haven't talked about is a line intersecting a circle at 2 points. It's called a secant. We have, however, talked about a chord, which is basically a part of a secant. It's what's inside the circle. So in that diagram, we have a chord intersecting a tangent. Since that angle is still on the circle, we treat it as if it's an inscribed angle. So the measure of the angle formed by a tangent and a chord is also half the intercepted arc. So in problem 3, angle DBC is that angle formed by a tangent and a chord. It will be half of its intercepted arc. Oh, but darn it, they didn't give me the measure of arc BD. They gave me the measure of arc BED. They told me that that arc on the other side of the angle that I'm trying to find. What do? One person. Okay, start by subtracting this 214 from 360. That gives us 146. What did I just find, Kate? Arc BD. And then what do? Take half of it. Okay, so once again, let's rewind a little bit. Earlier in this chapter, when we were talking about finding segment lengths, what property did we use the most? What did we do a lot of? We did a lot of Pythagorean's theorem, remember. We had tangents that were perpendicular to a radius. We had chords that were bisected by diameters. So we had a lot of Pythagorean's theorem going on. In this lesson, do we see that we have a lot of 1/2 going on? Okay, so as we're finding angles, continuing on through this chapter, you'll see that we are continuing to take half of arcs in order to find angles in, on, and outside of a circle. Finally, there's a your turn on the screen and a daily quiz on Socrative has been activated. There is a daily quiz on Socrative. It is activated. Love it. Yes, ma'am. Okay. Today would be fantastic. Yes. All right, so X, notice, is an angle formed by a theta. Of course, so it is half of the intersecting arc. Right? So big one is not noted. But I do know that this inscribed angle is 35. Remember, if inscribed angle is half of the intersecting arc, then the arc is double the inscribed angle. This arc is 70. And then so how the angle, again, taking half of it and back up that. Yes. I got one. All right, let me go ahead and talk about that up here. Okay, so in number 3, gentlemen and ladies, waiting. In number 3, part A, from what I've seen and heard, finding angle Y is no problem. You see the 90-degree angle, you see the triangle, and you remember what's tattooed on your soul, that the angles of a triangle add up to 180. Yes. So most of you had no trouble finding that Y is 55. X, however, is kind of baffling some of you. So think about it. Notice that 35-degree angle at angle Q. It's an inscribed angle. As we noticed earlier, if I have an inscribed angle and I want to use it to find an arc, think about it. If the inscribed angle is half its intercepted arc, what would I do to the angle to find the arc? Double it or multiply it by 2, same thing. So this arc then measures 70. And that's what you needed to know in order to find X, which is the angle formed by the chord and the tangent. And on the last screen, I just told you that an angle formed by an, I lost my train of thought. An angle formed by a tangent and a chord is half the intercepted arc. So we just doubled that arc to do what to it? Take half of it again. Okay, so angle X is 35. Which kind of, if you read ahead and looked at part B, you would have noticed that angle Q and angle KJL, ladies, are intersecting the same arc. and both of them have their vertex on the circle. So those two angles will be congruent. Again, if you haven't already logged on to Socratic to take the daily